In this video we're going to talk about a very interesting problem called the birthday problem, and this is of interest to lots of people for many different reasons, because people tend to get excited when they run into somebody who has the same birthday as them, and it actually turns out to be the case that in a large group of people, having the same birthday is, at least having a couple of people with the same birthday, is actually not that rare. So the question that we want to pose is, what's the probability that at least two people in our class have the same birthday? And we're going to assume there are 40 people in the class, and we're not talking about the same day of the we're talking just about the same day of the year, not the same year necessarily. So push pause, think about that for a minute. If you've got 40 people, what's the probability at least two people have the same birthday? So you want to think about this and try and come up with a number that that tells you, that reflects your, maybe it'll be a subjective probability if you don't quite know how to quantify this. That's quite all right. What I'm really hoping for here is to get a gut reaction from you, and so you can see what how your intuition does when it comes to a question like this. So one way to think about this is to say, if we have 40 people, how many pairs of people are there? So if we have just two people, then of course there's only one pair, and you would think the probability that those two people have the same birthday is very low, and that would be true. But when we start getting more people, what happens is we get more and more pairs of people. So 40 people, there are, turns out, 780 pairs of people. And that 780 pairs of people actually comes from 40 choose 2. If you have 40 individuals, how many ways can you choose 2 of them? That's 40 factorial divided by 38 factorial and 2 factorial. So this is an application of combinations. Now, we're not talking just about pairs here. We're actually saying at least two people. So it could be that we have 3 people have the same birthday, or 4 people, or 5 people, or we could have 2 sets of people of 4 people, so 2 sets of 2 different people that have the same birthday, that are different from each other. So you have 2 people born on August 2nd, 2 people born on September 3rd, and that would also be included in this. So the way to find this probability is to say, let's find the probability of no shared birthdays. So probability of 40 unique birthdays. And then we're going to subtract that from 1 to get the probability of at least 2 people having the same birthday. So the probability of 40 shared birthday, or 40 unique birthdays, is just going to be the number of ways that we can have 40 unique birthdays. So the first person, here we go back to the fundamental principle of counting. The first person can be born on 365 days of the year. We're ignoring leap year for now. The second person can be born on 364 days of the year. Third person, 363, and so forth, until we get down to 365 minus 40, and then there's actually a plus 1 right there. And that's the numerator. That's the number of ways we can have 40 unique birthdays, and now we need to divide that by the number of ways that we can have 40 birthdays where there are no restrictions. So the first person can be born on 365 days. 365, 365, 365. So this looks an awful lot like 365 factorial divided by 345 factorial. Sorry, not 45. That would be 325 factorial, and then all of that divided by 365 raised to the 40th power. So this is just 365p 40 divided by 365 raised to the 40th power. So p is the number of permutations. So because we know about permutations, we can now talk about this. And so if we want to know the probability of at least 2 birthdays shared, it's just going to be 1 minus that. So 1 minus 365p 40 divided by 365 to the 40th power. And turns out that number is 0.8912. So almost 90% chance of 40 people that at least 2 of them have the same birthday. So that's kind of a fun, interesting example of permutations, and you might want to think about this. See if you can get it to make sense, and try it with different numbers. It turns out that if you're in a group of 23 people, the probability is about 50%, and you can figure that. You can plug this number in to Excel to get that number. In fact, that's what I did over here. I said, you can see right here, 1 minus permute, so permute is the permutation, and function 365 comma 40 divided by 365 raised to the 40th power. So I can copy that, paste it, change this to 23, and you see the probability is almost 51%, just over 51%. And what's going on here is this denominator starts to get much, much bigger than the numerator as the number of individuals increases. And so by the time you get to 70 or 80 people, you're looking at over 99%. Well, let's just come over here and try that. Let's put in 90 people and see how high that probability is. So with 90 people, probability is 99.99994%. And a lot of people don't quite grasp this, or don't have intuition to help them understand that even with only 23 people, there's a high probability, 50%, 51% almost, of at least 2 people having the same birthday. Okay, so that's the end of this video. We will see you in the next video, which might be this week, it might be next week.